All right, guys, so here we are at section 2.2, properties of water. I need you taking notes in your notebook, please. So our key concept for this section is water's unique properties allow life to exist on Earth. So this presentation is all going to be about how those specialized properties of water allow life to exist. Our vocabulary: hydrogen bond, cohesion, adhesion, solution, solvent, solute, acid, base. And lastly, pH. Oop, I missed one. Buffer and indicator. Sorry about that, guys. Our main ideas. Life depends on hydrogen bonds in water. Many compounds dissolve in water. Some compounds form acids or bases. Essential questions. What properties of life are essential for the survival of living things? How are hydrogen bonds similar to ionic bonds? What are the solvents and solutes in a beverage that you drink? What are the differences between acids and bases? And life depends on hydrogen bonds in water. And water is a polar covalent molecule. So what does that actually mean? Well, if you remembered, covalently bonded compounds share electrons, okay? So water is covalently bonded. The oxygen is sharing electrons with the hydrogen, but because the oxygen is way bigger than the hydrogens, it's kind of like a bully, and it wants to pull the electrons more towards itself than sharing equally with the hydrogens. So what happens is, because it's pulling more of the electrons towards itself, because it's a bully, it's trying to take them away, we have these regions that become a little bit positive and a little bit negative, just like the poles of like a magnet, where you have a positive end and a negative end, or like a battery, positive and negative. So it pulls it just slightly. They're still sharing, but not sharing quite equally. So polar molecules have slightly charged regions, and that's because there's an unequal sharing of electrons. Now, one very common question for you to be asked on the EOC is, what is a polar molecule? What does that mean? And what a polar molecule is that we have slightly charged regions due to unequal sharing of electrons. So please write that down. I know I don't have it on the slide, but polar molecules are done because they have an unequal sharing of electrons. So nonpolar molecules do not have charged areas. And what can happen between our water molecules is we can have these things that are additional bonds between the water molecules called hydrogen bonds. And those hydrogen bonds form slightly between the positive hydrogens and the slightly negative oxygen atoms, okay? So it forms kind of like this little woven pattern, okay, where these little hydrogens, because they have a partial positive charge and those oxygens have a partial negative charge, they allows them to bond to themselves. And hydrogen bonds are responsible for four important properties of water. They are cohesion, which we can also call surface tension, adhesion, which means universal solvent, high specific heat, and water's ability to be less dense as a solid. And if you look at my picture here, the water surface on the left is curved down because water has greater adhesion than cohesion. We're going to talk what that means. And the surface of Mercury is curved up because Mercury has a greater cohesion than adhesion, but water has these special properties. And so when you pour water into like a little tube, it can bend just a little bit because these water molecules that are close to the glass are more attracted to the glass than they are to each other. All right, so our first property of water is this thing called cohesion, which is called surface tension. It's the attraction among molecules of the same substance. So in other words, the water is sticking to other water molecules, just what we saw when we looked at the hydrogen bonding slide. The water molecules are kind of forming like a little lattice here, where they're forming these bonds. And because of that, it forms like a little ladder, and that's called surface tension. It allows little things like water bugs, leaves, other things to be able to float or walk across the water. one type of lizard. This one is called a basilis. Sometimes he's referred to as a Jesus Christ lizard because he can walk on water and run across the surface. But surface tension is that ability for animals or other little things to either float on the top of the water or to run across it very quickly, because it forms like the hydrogen bonds form this like little ladder on the surface. Our next one is adhesion. Adhesion is the attraction of molecules of different substances. So in other words, water is sticky to other things, okay? And adhesion actually helps plants transport water from the roots all the way up to their leaves because the water is sticking to the sides of the plants, okay, in a process called capillary action. And we're going to watch a video about that. And I'll have the link for the video after the PowerPoint. If you're in class with me, we will watch the video right away. Okay, the next one, high specific heat. So in water has a high specific heat. And what that means is it takes a lot of energy to change the temperature of water. Okay, it takes a lot of energy to boil the water. It takes a lot of energy to freeze water. Okay, so because it has hydrogen bonds, it resists changes to its temperature. So the water actually helps life survive when it gets really cold outside because maybe the water doesn't freeze solid. And also if it gets really, really hot outside, water retains its temperature so it doesn't change. It's not the same as the air temperature. So our oceans aren't boiling and our rivers aren't freezing solid, or our oceans aren't freezing solid. So water helps to maintain homeostasis by keeping stable temperatures. All right. So high specific heat means that it takes a lot of energy to change the temperature of water, both making it too hot or removing energy to make it cold. The next thing, water is less dense as a solid, again, due to its hydrogen bonds. So when you freeze water and it becomes ice, the molecules actually space themselves out. They become less compacted, okay? So when they space themselves out nice and organized, they're less dense. And that's what allows the ice to actually float on the top of the water. And that actually helps living things survive underneath the ice because it acts as an insulator and keeps the water temperature warmer down below. Many compounds dissolve in water. So a solution is formed when one substance dissolves in another. A solution is known as a homogeneous mixture, same throughout. Homogeneous means same throughout. And solvents dissolve other substances. And solutes are the little particles that actually dissolve. So if we talk about a solution, we have the solvent part and the solute part. The solvent is generally the liquid that does the dissolving, and the solute is the particle that gets dissolved. So if you think about like iced tea, in an iced tea, let's say you have your tea and you have your sugar, right? Well, you pour your sugar in it, your sugar is going to be the solute. It's what we want to dissolve. The solvent is going to be the tea, the liquid that's going to do the dissolving. Now, we have to think that like dissolves like. So polar solvents dissolve polar solvents, all right? Now, nonpolar solvents dissolve nonpolar solutes. So you can think about this like oil and water, they're opposites, okay? Fats and oils are nonpolar, they don't have a charge. So when you pour oil in water, they don't mix at all, right? They can't dissolve each other because they're not alike. So polar substances and nonpolar substances generally remain separate. And then we also have some compounds that form acids or bases. And an acid releases a hydrogen ion, charged hydrogen, when it dissolves in water. So we have a high H plus concentration. And you can find acids on this acid-base scale. If you remember, it goes from 0 all the way up to 14. But an acid is anywhere from 0 to 6. The stronger the acid, the lower the number. So if we have something that's a 1, that is a super strong acid. It's more acidic. A base removes hydrogen ions from a solution, so it's a low H plus concentration. And now we can find those on the pH scale above 7, so 8 all the way up to 14. And again, this is the opposite. So a strong base is going to be at number 14. A weaker base is going to be at like number 8 or 9. Okay. And then a neutral solution has a pH of 7, and like something like water. Water is neutral, so we're going to find that right at 7. So most organisms, including humans, need to keep their pH regulated, okay? And within a very small range. We like our water to be right around 7. We don't want it to be very far from that. We don't want it to fall too acidic or too basic. And pH can be regulated through this thing called buffers. And buffers are things that neutralize a strong acid or a strong base. We can also use indicators to determine the pH of a substance. We have natural indicators that will change color depending on if it's a base or an acid. We can use things like litmus paper. You might have done an experiment in the past using litmus paper. It changes color depending on if you're using an acid or base. But indicators are chemicals that can be used to determine the pH of a substance. So the last thing I want you to do is go through and try to answer those essential questions. And then please, again, if you can't answer anything, you don't know how to do it, you need some extra help, just